So welcome to the Children's Center Science Day. We have a few experiments for you this morning. Diana is going to show us a physical change reaction. Jim is going to be showing us a chemical reaction, and I'm going to be going over air pressure. So take it away, Diane.
Okay, I have a can, and in this can I have it filled with ice cubes, and I have water in the can. And on top of the ice cubes, I have salt, just regular table salt. What we're going to show today is that the salt lowers the melting point of the ice. So therefore, my ice will stay formed, but it will also make the water seem colder. Because around the can, the temperature will fall below freezing as well, and that's why you develop frost around the can. You will be able to see, like if something is left outside and it gets really cold. It's because the water vapors make condensation, and you get this frost developing around your can, but your ice will not melt. So our ice is still here.
Look at the ice.
It's got the salt on there, and you're going to see, you feel the can, it's really cold down here. Feel how cold. Yeah, feel how cold it is.
Feel how cold it is? Touch it. Look at it.
Yeah, the salt is making the water really cold because it's going to be really cold. Yeah, it is. Yeah. Is it? Well, look at there, buddy. Yeah.
We're talking about volcano geology today. Yeah. So this is like a volcano. So layers of ash and lava are cracked open from pressure from below. So the molten magma rises through channels towards the Earth's surface. It flows out as lava. Once magma comes above the surface, they call it lava. And the ash spews out, and then the lava covers the ash. And this process happens over and over again, which will help form the cone of the volcano. Magma reaches the Earth's surface called lava, and lava is between 1,000 to 2,000 degrees Fahrenheit, depending on what kind of molten rock is involved in the lava. So, maybe we should put it down here.
Okay.
Seal the hole, seal up. Going back away.
Oh, look. Look what it's doing. Wow, cool.
All right, so let's talk about air pressure. Air pressure affects the weather. We got high and low systems. These weather systems, the high pressure systems, usually don't have a lot of moisture, and they move pretty fast. They have a lot of energy. The low pressure systems are heavier and slower, and a lot of times they build up with water because as these high pressures are zooming by, it pushes those low pressures high up into the air. That water vapor that's in it condenses, and that's why you have a lot of precipitation with your lower pressure systems. And it always flows like this. Inside the balloon you got high pressure. It's contained in here. Where does the high pressure want to go? It wants to get out. It wants to move. The high pressure always wants to move. So let's do some experiments with high and low pressure. All right, so pretend these are our clouds. These are just water bottles filled with water, right? Pretend these are our low pressure clouds. We got some clouds in the sky right now. They got water in them, and they're fine. They're just floating around. It's all good. But what happens when a high pressure system comes in, blows in, and pushes those clouds a little bit further up? What happens? When those high pressure systems hit the low pressure system, they push in. So when those low pressure systems come in, the high pressure comes in, pushes that low pressure up, and what do you see? Rain. So there we go, that high pressure system pushing on that low, and now it's raining everywhere. that high pressure system comes in, and now we got even more rain. Easy enough, right? Whoa. So high pressure is always pushing. It's always pushing. So again, here's my moisture, low pressure cloud. It's fine. Pressure is okay. It's just floating around. If I put this on top, it's not going anywhere. It's too fat. It can't go inside at all. But what happens when the pressure changes? What I'm gonna do is cause a pressure imbalance. So right now, the air pressure here is the same as outside. It's fairly low, or I mean it's fairly high. What I'm gonna do is put some paper in and light it on fire. What that's gonna do is burn up the oxygen and make it a lot lower pressure inside when I plug the top. Now when it's a lot lower inside and it's a lot higher outside, that high pressure is going to push. Let's see if that's the case. With that flame inside, will it go in? I don't know. Might pop the balloon on me. Not enough fire. Or is it? See it starting to squeeze? Is anyone brave enough to get close? See how it's getting pulled in? Not quite in. Maybe I blew it up. I put too much water in it. But you can see how it's close, right? It's close. It's trying to squeeze in there. I don't know if it'll make it though. We'll see. I'm just gonna leave it here. And if all of a sudden it pops or all of a sudden it goes inside, we'll see. So I'll let it go for now. Jim, are you ready?
Magma and the pressure pushing up from the bottom of the earth, out of the earth. And the cool rock rolls of magma inside the volcano this time.
Doesn't want to come out.
Almost burst, but it's not burst.
Oh, that's very tight. You got your bag is too strong. You got the brand name.
Should have gone with the DG. Boom!